Muy buenos días, damas y caballeros. Un placer para nuestra Universidad Tecnológica del Cibao Oriental, UTECO, recibirles en ocasión de este encuentro en el cual tendremos dos conferencias. Universidad UTECO unida con la Universidad AGH de Ciencia y Tecnología de Cracovia, Polonia.
Good morning, ladies and gentlemen. For us, a pleasure to have you here. We're going to have a great conference. With the agreement we have with the HGA University, University of Science and Technology, and we're going to have two conferences here.
Nosotros como universidad altamente complacidos de recibir esta delegación que nos visita, adjunto de los estudiantes de inglés por inmersión de nuestra universidad.
We're highly pleased to have this delegation from HGA and also the English Immersion Program to the students of this university.
Placer para nosotros de inmediato pasar a nuestro vicerrector académico de nuestra universidad con las palabras de bienvenida, licenciado Herminio Vázquez.
So we're going to listen to our vice rector with some welcome remarks.
Good morning, student.
Buenos días, estudiantes.
A little English.
Un poco de inglés.
Muy buenos días.
Good morning.
En nombre de la universidad, queremos hoy a ustedes, los estudiantes, darle la bienvenida a este hermoso encuentro de transferencia de conocimiento.
On behalf of the university, we want to welcome you students to this conference where we're going to share and transfer knowledge.
Y aprovechar la oportunidad para, en nombre de la universidad, a esta honorable comisión de técnicos de Cracovia, por estar acá en la universidad compartiendo experiencia, pero sobre todo para allanar los caminos para buscar un acuerdo de cooperación interinstitucional.
We're glad to have the delegation from Krakow University here so they can share the knowledge they have and we can strengthen the agreement we have with the HGA University.
Su presencia aquí en la República Dominicana y sobre todo en la UTECO está dejando huellas que van a ser imborrables para la universidad iniciar un proceso de interacción, sobre todo con esa gran nación que es la patria de Juan Pablo II, muy querido aquí en la República Dominicana.
Your presence will leave an erasable footprint in here this university, and also we're glad to have the homeland of John Paul II.
De manera pues que lo que nos queda entonces es aprovechar hoy esta doble conferencia de estos técnicos de Cracovia para que ustedes le saquen el mejor de los aprendizajes. Y en el caso específico de ustedes, los estudiantes que dominan ya el idioma, pues le va a servir de práctica y espero que los profesores luego los reciban para interactuar de todo lo que han recibido hoy acá, como forma de certificar que recibieron la información y la asimilaron.
So we want guys you to take advantage of this great opportunity to have this double conference, so you can take advantage of it and also share the knowledge with your peers and with the professors in the classroom.
Bien. De manera pues que dejamos el escenario con ustedes a estos distinguidos técnicos de la Universidad de Cracovia para que pongan a disposición su competencia y su conocimiento en las áreas que ellos van a explayarse aquí hoy con ustedes.
So we're going to give the stage to the delegation from Krakow, who are going to share the knowledge that they have, the technical knowledge that they have. about the different topics that they're going to discuss this morning.
Finalmente, mucho abrazo a ustedes, a los estudiantes, pero sobre todo a esta comisión de Cracovia que nos honran con su presencia acá en este día y que lo vamos a extrañar con su partida esta tarde.
So hugs for the students and especially for the delegation who are from Krakow who are here, and also we're going to miss you because you guys are leaving this afternoon. So for us it's a pleasure to have you here.
Muchísimas gracias.
Thank you very much.
Muchísimas gracias, nuestro vicerrector académico, licenciado Herminio Vázquez. Nos permitimos llamar a nuestros conferencistas que por favor ocupen el set principal. La charla Ventilación de Túneles, expositor Dr. Rafael Lucrash, especialista en ingeniería ambiental.
A conference about tunnel ventilation. You can come to the front. You can come to the front. And this is the engineer Rafael Lucrash.
Nuestro segundo conferencista, Minería Oceánica, expositor Krzysztof Broska, coordinador Cooperación del Caribe y Oceanía.
Okay. Our second participant is going to be Professor Krzysztof Broda, who is the coordinator of cooperation of Latin America, and who is the coordinator of cooperation of the Caribbean, and also is going to talk about the deep sea mining.
Estamos en vivo por nuestro canal de YouTube, UTECO RD. Esta oportunidad, Universidad UTECO, Universidad AGH de Cracovia, Polonia.
We're live on YouTube, UTECO RD.
Nos permitimos saludar a las distinguidas personalidades que acompañan esta delegación desde Polonia.
We're glad to say hello, to greet and welcome the rest of the delegation that are coming from Krakow. We have Professor Marek Borowski. Barbara Luchat. And Magdalena Wojtowicz.
Bueno, y desde la República Dominicana saludamos Miguel Peña, asesor minero del Poder Ejecutivo.
And for the Dominican Republic, Miguel Peña, advisor of the Executive Power.
Profesor de nuestra universidad y director del Servicio Geológico Nacional, Edwin García Coco.
García Coco, director de Geology Service.
Que vino con su fan club.
He have a lot of fans.
Sí. Resaltar también a todo el equipo de trabajo de lo que tiene que ver con posgrado, coordinación de la carrera de geología, también el decano de la Facultad de Ingeniería y Recursos Naturales. Para ellos, un bonito aplauso y todo el equipo que ha estado trabajando.
A big round of applause for the whole team that have been working from the postgraduate department, and also from the School of Geology.
Y para aprovechar el tiempo, pues vamos a dejarle con estas dos conferencias sin desperdicio. Alfredo Acosta en español y el director de la Escuela de Idiomas de nuestra universidad ha estado compartiendo con nosotros como traductor Alfredo Joel Otáñez, quien hará la presentación formal en inglés.
So it was a pleasure. I'm Alfredo Acosta, one of the broadcasters of the university, and also Alfredo Joel Otáñez, the one who is translating right now. We'll be splitting the languages in English and Spanish. However, our speakers are going to have the conference in English. So you guys, the ones who are studying English, most of you are going to delight yourself listening to English language.
Entonces, con ustedes, pues nuestros conferencistas en el área de ventilación de túneles y minería oceánica.
So now our speakers, we're going to be talking about tunnel ventilation and deep sea mining.
Con aplauso de ustedes, muchísimas gracias.
Three round of applause. Thank you very much.
Estamos en vivo a través de nuestro canal de YouTube, UTECO RD para todo el mundo, desde la Universidad Tecnológica del Cibao Oriental, UTECO.
And the screen will be displayed over here. Okay, one second. Yeah, well, we have this computer.
El connect to?
Yes, this a wire over there, this cable.
Okay. Up there, this computer. Okay, so
Yeah, it's maybe displayed in a few minutes.
Proper ventilation is the basis of safe operation of road tunnels. We see different tunnels inside, outside, in the design. Ventilation system is used on the stage of drilling and exploitation. It's very important drilling time with safety building these tunnels, and exploitation with driving and moving in the tunnel. The all of tunnels in Poland, I got to three groups. The first group is the tunnels in construction in Poland. The table includes information about tunnels in construction. We see the name of tunnels, location, length, cross-section, and deadline. In construction, we have 7 tunnels. In location, for example, Zielonki, Batowice. The length of tunnels is more 2,000 meters. Cross-section we see in Polish dwie jezdnie po 2 pasy ruchu. In English means 2 naves carriageways. The cross-section may be 1 nave or 2 naves and carriageways. Deadline is the date opening the tunnels to exploitation. Next group, we see planet tunnels. In Poland, this is 6 tunnels, 2 tunnels in Warsaw, 2 in Kielce, and 1 in Police. In Police, tunnels is most length, about 5 kilometers. The last group, this is existing tunnels. In the red square, you see more length tunnels first in the city, in Warsaw, more 2.3 kilometers, and second tunnel in Luboń Mały village. This is tunnel near Kraków, on the road between Kraków to Zakopane, to Tatry mountains. This is next existing tunnels, more in Kraków, Trasa Łagiewnicka, Toruń, Wrocław, and third of Perch, Trasa Łagiewnicka in Kraków. We saw 26 existing tunnels, but we have 27, but the last I saw later the tunnel in Węgierska Górka. This is tunnel in construction. Proper ventilation on the road tunnels should ensure first air exchanging, which reduce construction of gases in the air, construction of ducts in the air of tunnels to level, which is specific in Polish law. Air velocity and air temperature parameters is very important, which are regulation by climatic conditions in the tunnels, and the possibility of evacuation of people from the tunnels in the case of fires, for example. The ventilation system should meet the specific criteria for normal and emergency conditions, and should be cheapest technical solution, ensuring maximum safety for people, for drivers using the tunnels. In the world, the ventilation and safety in communication tunnels are the subject of many analyses and research topics and designs project, the tunnels. Ventilation system during tunnel drilling, the parameters like geological and mining conditions, technologies, natural hazard, as well as sources of pollution. The pollution should be analyzed in detail during project the tunnel. The main sources of the pollution are of carbon dioxide, carbon monoxide, nitrogen oxide, as well as gases and dust produced by technological devices in process of mechanical rock mining and the transport of rocks, for example. Ventilation systems are used not only for cleaning pollutions in the air in tunnel, but also when the temperature increase in the tunnel for decreasing the heat emitted by the rock mass and from blasting. In the systems of during tunnels, we used the system suction. This is a supply system. We see outside the excavation fan, an inlet to the ventilation duct, and the air movement direction in the excavation. This is supply system. The second system is the pumping or exhaust system. In this situation, we have the fan outside excavation, and air movement is in the excavation outside, and we see exhaust from the ventilation duct. The third system is the mixing, one and second system. In this system, we exhaust the air in excavation, outside, in excavation, or outside the excavation. Ventilation of rough tunnels is natural or mechanical air exchange. Mechanical tunnel ventilation system can be divided to lengthways or cross, and the last systems are mixed, semi-transverse. The first system, the airflow takes place along the axis of the tunnel between inlet and the outlet of portals, or between two portals and the ventilation shaft. In this system, we often use special fans, that jet fan, located under the ceiling or in the shaft. And advantages of mechanical longitudinal ventilation system is most airflow included by jet fans, exhaust fan in ventilation, and the special system named Saccardo nozzle system. In the longitudinal system, we not to run ventilation ducts. This is preferred in one-way tunnels and used in tunnels with uninterrupted vehicle traffic when the velocity is more 20 kilometers per hour, and small longitudinal inclination. Transverse mechanical ventilation is used in long tunnels and which high traffic intensity more velocity in the tunnels. In the inlet and outlet section, the air flows transversely to the exit of the tunnel. Between the section, however, the air movement is longitudinal. In the picture, we say exhaust is under the ceiling and the fresh air is supply near the road. The first system is the mixing semi-transverse ventilation in combination transverse and longitudinal ventilation system. In the system, we see exhaust of air in ceiling, but the fresh air flows direction in the tunnel. In other hand, inside this semi-traverse bottom wall ventilation system ensure air supply to tunnel by means of the duct. We see the supply of air is near road, and we see special holes to flow the air, and exhaust of the air is long and flow natural in the tunnel. This is mechanical mixed system in ventilation of in the tunnel. I don't know if you see, but near the road we see the hole to supply system, and under the ceiling we see two fans. There are jet fans. For example, I show you the tunnel who is driving, because this is the tunnel in Węgierska Górka. He is on expressway C1 between city Bielsko-Biała, Żywiec and Zwardoń. The length of the tunnel is 830 meters and height 4.7 meters. You can see the tunnels inside. We see ventilation pipe and phase of exploitation, the dampers device on the side right. This is a special picture for you all. Who knows that? It's snow, yes? Yes. This is winter. This is winter in Poland. And the snow is on the ground. We see all is white. On right side, we see ventilation pipe and inlet to the tunnel. To move the air to the tunnel, we used Atlas Copco fan. And on the left side, we don't see here, is Túneles when we use Korfman duct fan. In drilling the tunnels, we often make measurement of parameters of air as volumetric concentration of selected gases as oxygen, carbon dioxide, carbon monoxide, nitric oxide, sulfur dioxide, hydrogen, and methane. We measurement velocity and volume flow of air at the outlet from the air duct, in inlet to fan, and in the phase zone. We measurement dry and wet bulk temperature, humidity and air pressure. In the system, you see, in the picture, you see the system ventilation of the tunnel in Węgierska Górka. The minimum distance of the fan from the inlet of the tunnel is 20 meters, and the distance from the face of long walls is 10 meters, but in tunnels of Węgierska Górka, the distance is 20 meters. Because there was a problem with temperature in the winter. In Polish mining regulation, we have a maximum concentration of gases. You see the carbon dioxide content greater than 1% and others gases, but the oxygen content must not be less than 20 by volume. In detail, you see the parameters in the tunnel, the gas concentration when no machines running on the phase of excavation. Oxygen is more 20%, is very good. Carbon dioxide, the concentration is normal, about 300 ppm, and the second columns, we see gas concentration with the driving rig running in the excavation. We see increase the concentration. For example, carbon dioxide increased to 0.5%. Carbon monoxide increased 0.2 ppm, nitric oxide equals 0.8 ppm. The temperature increases about 3 Celsius degree. The flow efficiency is the same, and air velocity is probably the same, about 0.3 meters per second. The measurement in drilling tunnels, we measure the parameters in exploitation tunnels. We see the construction on 3 stages. We have per 3 anemometers to measure velocity, and we can make a profile of flow in the tunnels in the natural ventilation or in mechanical. The construction is on services car. Thank you for your attention. Have you got the questions? Maybe?
Any questions? No questions. Okay, no questions. Okay.
to know if they take the same. How can I explain that? I'm sorry. If you take the same. This? La verdad es en español, ahora me siento un poco nerviosa. Yo quiero saber si se toman las mismas precauciones en cuanto al sistema de ventilación o dependiendo de la temporada del año, ya sea invierno o verano, o si en el caso se toma el mantenimiento es distinto dependiendo de la temporada del año, porque tomamos en cuenta el factor de la nieve.
The gases concentration. She asked about the concentration of pollutants winter and summer. The concentration is not the same. That it depends of the numbers of vehicles in the tunnels, because in tunnels we use the machine with engine. I show you two situations. First, without working the machine, and the second with only one machine. Then if you use more machines, 2, 3, the concentration will be higher. And if the concentration of gases increasing, we have to change the velocity of air in the ventilation pipe to reduce the concentration in the excavation.
Is that understood? ¿Entendiste? Yeah, okay. Yes. Yeah, that's what he answered. Because it's different seasons.
We haven't difference between winter and summer, because in the tunnels works the same machine in summer, and the concentration in the same outside the tunnels, winter and summer. Only temperature is changed because in summer is very warm, but in Poland in the winter we have very low temperature, about minus 20 Celsius degree. Not as Dominicana. Okay, okay. I stay here.
Okay, any other questions? We have another question over there.
Hello, my question is, what is more important, the air enter or leave? Sad.
Both situation is very important. If the concentration in the inlet air is high, we will have inside more concentration, yeah. And we have to change the velocity in the air in the duct and choose the parameters of fan.
Thank you.
Chcesz pomóc, Marek? Thank you very much.
Hello, everybody. My name is Krzysztof Broda. I'm also working at the AGH, and I will be talking today about deep sea mining. I see, so some of you are standing. There is a hot, so my presentation will be very short, less than 30 hours, so we so we can start. In 1961, on the World Congress of Geology, the President of the US States, John Fitzgerald Kennedy, says that from the beginning of civilization, every nation bases wealth and progress has stemmed in large measure from its natural resources. Our entire society rests upon and it's dependent upon our water, our land, our forests, and our minerals. How we use these resources influences our health, influences our security, economy, and well-being. And nothing changed from that time. Why we should reach the depths and take from the bottom of the sea minerals. Because a lot of resources on the land, it's not produce not enough elements for our industry. For example, copper. If we look at this picture, the blue is the copper production, 1,000 of metric tons. The green line is how rise the world population, and the red is per capita consumption for per persona. So we see that the production is a very big rise from year to year. But if we looked at the demand for copper in the year 2012-2030, we see, if we check the China at 6% growth, we haven't about 15 million ton of copper less. It's not enough. So we should take it from the sea, because the land resources of copper deposit are exhausted. We can see how the production is going on these years. So which problems we have with exploitation under the sea? It is the primarily research with some pilots test. It's a very innovative part of mining, and I think it's very hard. More question we should answer than with space mining. So it's very hard because of the high pressure. Other deposits under the sea, political restraints on ownership, I will be talking about it, economic recession, and technical and processing problems. Sometimes we find on the land new deposits, so then there's sufficient land-based deposit, and maybe in the last years declining interest for deep sea mining. And of course, very dynamic onshore mining, oil and gas, and another fossils. So, if we look at this slide, we see that more than 10,000 alpinists reached the Mount Everest, 12 astronauts were on the moon, and only 4 persons were in the deepest place on the world. So you can see the problem. We should answer some question whether sea mining is the future of minerals, raw materials, sourcing solution for future generations. And the most important question, is it possible to develop marine mining in a sustainable way without damaging environment? We did it on the land, so don't do it under the sea. Who could exploit the seabed? The rules are on the law of the sea. The name is UNCLOS, and we have this a mart of parties to the United Nations Conventions on the law of the sea, and we have seen the first is the land. The land is state-owned, and the tide lands also it's the state island. And another is the territorial sea. Territorial sea is treated like land. All the laws, rights to the country. But another is contiguous zone and exclusive economic zone. You know, in this territory, the country has the rights to permit to exploitation, to research, etc. But it's not as strong as on the territorial sea. And what we make a lines of these borders. The territorial sea 12 miles from the land. If we have if we have an island, it is 12 miles from island. From the shoreline is 12 miles, etc. It is also how we look. And this legal regime of the oceans and airspace, it's here. You know, on the world, from the 16th century, we are talking about the freedom of the seas. Yes, it's freedom for the ships, not for exploitation. Till the 200 miles of seabed exploitation, there is no freedom. But after this zone of exclusive economic zone, there is open seas which belongs to all the people on the world. And so it is the map with this exclusive economic zones, and this light green, it is international waters, this free waters, and the International Seabed Authority, it is the United Nations organization, intergovernmental body based near the Dominican Republic, because in Kingston, on Jamaica, and decided about organization and making a new law for exploitation international waters. So, how to start this exploitation? No, you must be a investor which invest in the beginning minimum $30 million for research, and after it we can apply it to the ISA for an area about 300,000 square kilometers. The ISA give us 150,000 square kilometers. And it is the area where we should do research. After each year, this area is closer and closer, and in effect, we stay about 75,000 of square kilometers. And look, it is the polymetallic nodules exploration area in the northeast Pacific, Clarion-Clipperton fracture zone, and this different areas for countries, for some firms. For example, Poland has this area, sorry, Clarion-Clipperton. It is where is this? I have inter-ocean metal here. This and this. What we exploit underwater? For example, the not deep sea mining, because these elements we possess from the deepest about 200 meters, no more. So aggregate sand, titanium, phosphites, gold on Alaska, tin, platinum, so everything is underwater. So only to dive. And very rich area of elements are on these ridges, volcanic ridges in the oceans. And what are the advantages of deep sea mining? The first is limited social disturbance, for example, for community on the islands, on the shores, etc. Increased worker safety. The work on the sea isn't very safe, it's danger work, so we have to make this work safe. Less climate relevant emissions, minimal mining infrastructure, minimal overburden on stripping, minimal mining waste. These are advantages we should solve. Seabed exploitation from antiquity to the 20th century was by buckets, venturing out of the boat, diving from the boats, all collection from the beaches. You know, everything changed in 1875 when was the HMS Challenger set sail in December 1872 and discovered the deepest place on the Earth in Mariana Trench. It is the Challenger Deep. And also during this race, they possess polymetallic nodules from the deep depth of about 1 kilometers. But then nobody interested in this. Now it is one of very good. But look, this slide I show you, it is the Lake Maracaibo in Venezuela. See this dark blue? It is an oil on the sea. It is wrong exploitation, not safe. It is from the orbit, from the cosmos picture. So it's a danger of deep sea mining. So what we need to research mineral resources, to find mineral resources on the bottom of the sea? At first, we need, what is? Tam, żeby kliknął w to okno, żeby kliknął w to okno. So moment. No, this. Okay. No? Not working. Okay, so we go. Oh, yes, marine mining equipment. So, marine geology, I think the father of marine geology is John Murray, which started his work between 1841 and 1914. And we need for geological research only a ship, only a research vessel which costs about $150 million. It's not more. It's enough, and it needs some different equipment, like of course global positioning system, multi-beam echo sounder, narrow beam sounders, precision depth recorders, narrow beam sub-bottom profiler, benthic multi-coring systems, large gravity corer, multi-corer, finder installer, free fall grab, finder mount, dredge bucket, a lot of equipment. It is why it is such expensive. And here I show you the methods, acoustic methods of finding resources. We have on the end of the vessel, we have on the frame an air hose with air gun, which makes acoustical wave, and a streamer with detectors, which is long about 2 to 5 kilometers. And it is how it works. And at the upper left, we see the geological structure of Polish Southern Baltic seabed recorded by high resolution reflection seismic, making by this air gun here, which makes acoustic wave about frequency 50 to 300 hertz. Another is profiling with higher 3.5 kilohertz. It's more sensible, but his range is not as long as with this acoustic frequency. So different maps, geological, it is these maps are from the same place in Gdańsk Bay in Poland. A, it's making by a boomer, B is making by a pinger, and C is making by a chirp. So that looks. Other instruments, it's measuring gravity anomalies on the bottom, but it's very expensive methods, and of course using some buckets, some dredges, vibration samplers, etc. As you see, and of course ROV, which are most advanced equipment for research. Of course, grabs, spiders, also grabs, research drillings, etc. Okay, how we possess minerals from the deep now? The first kind is minerals exploration, borehole methods, at gas, oil, later sulfur, mineral exploration, open cast sea mining methods, and mineral exploration underground mining methods on the sea bottom. Now these mines are closed, but these mines were on the shore, but exploration area was under the sea. It's a coal in England, coal and iron ore in Japan, this method. Of course, borehole methods, I will not be talking about it. And open cast sea mining till 200 meters. We use suction draggers, cutter suction draggers, trailing hopper suction draggers, bucket draggers, a lot of different construction. You can see here these draggers. Of course, they were used to build, for example, these artificial islands in Dubai, in Doha. They were made by these draggers. These methods, these artificial islands. No, and of course, what does woman like best? Diamonds, yes, of course. Most of the diamonds we possess from the sea, near Namibia, near South Africa. If you look at this map, these gray areas you can buy and explore diamonds. So, what is the techniques? We possess diamonds from the depth to the 300 meters. This is the bear's crawler, which riding on the bottom and collect here the rocks with diamonds, and it is hydraulically transported to the ship. You know, we possess from this area 95 million carats of diamonds. 1 carat, it is a lot or a small amount. 1 carat is a 0.2 gram. So divide by 5. So we have 17, 18, 90, 19, tak? 19 millions gram. 19 tons yeah, of diamonds. So look, okay. There's not connected. Okay. So crawler possess diamonds from the bottom. It is transported to the vessel, and this is the mineral processing, czyli the separation of diamonds going to the belt, and here is X-ray source, detector, and the gun with airjet. If detector detect the diamond, airjet push it, and the diamond's going to the left, and the rocks going to the right, and we have separated. So it looks here. But let's go in the end to the deep sea, very deep sea mining. You know, research of marine deposits and methods used therein differ significantly from those used for deposits on land. So this is a problem. We don't use the same machines, the same rules. It's quite different. It is due to a specific nature of the marine environment and the nature of deposits. It's the different nature. At present, deep sea mining is most interested in 3 basic types of deposits. First is the seafloor massive sulfides. Second is cobalt and manganese crust, and the third is polymetallic nodules. Differences between these types of deposit determines the differences in the technology of mining and production. Here is the surface of the sea and what is in the depth. Manganese nodules, it's more than 3 kilometers deep. Seafloor massive sulfides, it's about 1.5 kilometers till 2.5 kilometers. Gasohydrides, 1 kilometer. Diamonds, 200 meters, 300 meters, etc. And here you can see how it's the difference between exploitation. At this picture, we have exploration of SMS, seafloor massive sulfides, near the collecting the polymetallic nodules, and here this cobalt-rich ferromanganese crusts, etc. This seafloor massive sulfides, it is the richest ore under the water. It has about 15 to 20 meters thick, and we can find them in this ore, platinum, gold, also Ind. It's a lot of, nearly whole the Mendeleev table. So it's good, and it is near the hydrothermal vents. You can see it. Oh, and we explore it. Oh, have an internet, so good. Another is cobalt and manganese crust. The tin is about 6 to 10 centimeters. Poland has the area on the Middle Atlantic ridge with this kind of deposits. And of course, polymetallic nodules looks like on this picture. We collect them. We need more than 10 kilograms per square meter for economic reasons. And another pictures, and you can see the concepts of exploitation, underwater exploitation. We have 4 basic processes in deep sea mining: extracting, transporting, storage, and transport to the land, because the law of the sea don't allow to make mineral processing on the sea. You have to transport the deposits to land. Also some schemes. About technical rules I will not be talking now. So the projects. In Europe is the Blue Nodules project. It should be finished in 2019, but because of COVID, it still isn't finished. And it is the visualization of this project of exploitation. And in the end, I would like to say something about Nautilus Minerals and Solvara projects. It's a pity it didn't start, because they make everything. But they make everything. It is near Papua New Guinea, and it is the Jules Verne production support vessel, and this machine exists. They were built in Scotland and working, but now we haven't any on the international waters, we haven't any exploitation for industrial scale. So it's an auxiliary cutter, and this machine going first and cut the crusts for a flat position. Behind the auxiliary cutter goes the bulk cutter. That is the main machine which needs, and behind them goes collecting machine which collect the ore and by RALs, raising air lifting systems, transported to the surface of the sea. You know, this system of transport is the most expensive part of deep sea mining. In this Solvara project, it cost about $400 million. Yes. So, you know the cost. And Krypton Ocean project, I think it was to take money from investors and nothing do. So, their concept. So, and another rzecz, environmental impact. We still haven't enough data to say if it's safe for environment or not. We still have to make more research and more research to not destroy the environment in the future. Here is the creators from the bottom, taking, and the scientists counting them, and a year later, from the same place, they take a sample and counting in 5 years, and tell, so when the environment can rebuild after exploitation. So this impacts environmental noise, plums, sediments. It's very, very dangerous for environment as New Zealand. Thank you for your attention.
You have questions? Yes. Okay.
I have a question, maybe different for you. I would like to know your opinion on whether humanity will ever finish exploring the ocean.
The question, you didn't listen to you. Okay. He wants to know whether, in your opinion, whether humanity will ever finish exploring the ocean. No? Do you think so?
In my opinion, never will finish. Because, you know, we need a lot of things from the sea. Seafood, very good in Dominicana. Don't you stop possess seafood from the sea? No, I think no. Yes, the minerals also. But the question is how to do this in a sustainable way, not to damage the environment.
A few days ago, I saw a report, and some people from here, Dominican Republic, are not agree for the deep sea mining. What is your opinion about that?
Yes, you know, everybody has a right to say their opinion. That's no problem. But it is a very difficult questions. If we have a lot of, for example, raw minerals for energy transformation, etc., like in Europe, like in USA now, so we don't explore the resources underwater. But if we haven't, what we should do? From where? Have you a smartphone? Yes. Do you know what the components is made? Would you like to throw it up? That's the answer.
Sí, Miguel Peña. Muy buena su pregunta. Justamente en estos momentos se encuentra en acción lo que se llama el organismo de la Autoridad Internacional de las Aguas Profundas, como acaba de presentar el profesor Christoph. La presentación no podía ser más oportuna para justamente en esta universidad tocar este tema, porque es un tema importante para la humanidad y es un tema de geopolítica universal. Como ustedes saben, en esta presentación se hizo un esquema de lo que es el perfil tanto del potencial geológico, geoeconómico y también ambiental. El profesor muy bien delineó cuáles son las ventajas y desventajas. El país, República Dominicana, como miembro de Naciones Unidas, tiene un asiento en la Autoridad Internacional de los Derechos del Fondo Marino, que se llama ISA. En este preciso momento hay una sesión de 3 semanas que se está llevando a cabo en Jamaica, que es el país anfitrión para esta conferencia. La posición del gobierno dominicano, siendo ella una de mis recomendaciones como asesor minero del Poder Ejecutivo, es que se posponga la autorización de las explotaciones mineras de los fondos marinos, tal y como señalaba el profesor. ¿Por qué? Porque se necesita, tal y como él señalaba, más investigaciones, más evaluación de impacto ambiental, principalmente en esa zona donde existen los nódulos, porque allí se ha encontrado que existen una convivencia y un desarrollo de crustáceos muy importante. Quizás con un valor que pudiera también ser un beneficio de que pudiera extraerse esa fauna para ser usado para fines medicinales también en beneficio de la humanidad. Como vemos, su contesta final fue que ¿qué usted hace sin el celular? ¿Qué usted hace sin los minerales estratégicos? Entonces hay una posición mundial. Ya estamos alcanzando 7.5 billones de la población mundial, por consiguiente, casi 8. Entonces, ya la humanidad, tal y como señalaba él, está demandando más minerales. Por consiguiente, es un momento muy adecuado para esta universidad que hayamos traído este tema. Una cosa importante también, que a través de los convenios que estamos fortaleciendo con Polonia, en las últimas presentaciones que hemos tenido, hemos conversado, y eso ahí está también parte del futuro de ustedes. Hemos conversado con las autoridades gubernamentales de Polonia de que nuestro país sea parte de esa área especial que tiene Polonia, porque ahí está también participando Cuba y otras naciones de Europa. Y en el último encuentro que estuvimos con el Servicio Geológico Nacional, con Edwin García, en Argentina, estuvimos conversando porque ya hay un convenio entre el Servicio Geológico de Polonia y el Servicio Geológico Nacional. O sea que el futuro de ustedes también toma otro horizonte con estas iniciativas. Perdone que me haya extendido tanto.
If you have a question, thank you for your attention.
So thank you for your attention, people. We're glad to have this conference in English. It's great. It's great. I know that some terms are a little bit complicated because for some of you it's not your area, and so for some of you you are studying the career. I mean, you're beginning your career as an engineer or as a geologist, and we know that it's a little bit challenging. But this is what you have to think right now. You have to think about your future, and these are the things that you have to learn in the future. Right now, it's not very common to have the deep sea mining, but in the future, that will be necessary if we want technology, if we want the equipment, so that will be necessary. But we need to do it in a way that we can protect the environment. So guys, thank you for coming, and thank you. Meryl, do you want to do? Okay. Okay, you're pretty sure? Okay, come, no problem. Okay, we have a little bit more of the conference. Una ñapita, como decimos.
This One, two, three. On the end, I would like to say some words about mining, about minerals. Yeah, I would like to show projects. We cooperate with ABM Polska, Poland, sorry, and I would like mining in future, mining and at the moment and in the future. Yeah, I agree with my colleague. This is
projects about projects who cooperate together with IBM Poland about advanced analytic, about artificial intelligence. Yeah, this is our point of view or mining and minerals. Yeah, all is mining. Yeah, if you get a sand from beach, this is a mining. Yeah. Generally, we provide exploitation in underground. Your imagination in underground mining without people, in only automatization, yeah, machinery works without people. I don't know, but you think about mining, not only processes, not only exploitation, but you see is change value. You can see operation, asset management, digital vehicles, workplace, sustainability, and weather. All is very important. How this connect? You see, mining technology is not technology. Mining is processes, is people. You can see how many processes is connected with mining around exploitation, around open pit mine or underground mine. Next, you see the same processes in different places. Yeah, you see we have many data from these processes. Many data for us is very important for optimization, for efficiency these processes. You can see how we collect this data from these processes. We have this data on many levels. Yeah, first levels is 0 levels is operational level. Yeah, if you see next steps, next levels, when we collect many data, this is very important for us because we yeah, you see on the first level, on the down, you see we collect of this data. This is a layer, data layer, yeah, at the moment. Second, this is get this data. Second level is technology level, yeah. We learn, analyze, resolve problems, and on the end, we visualize, optimize of this data. We make a digital twin of these processes. Yeah. What is interesting because we want to understand these processes. You can see what is our priority is robotics and sensor and automatization.
México y también en la Universidad de Colorado. Entonces, él nos puede guiar para que se pongan algunas materias optativas en el área de mina. A los que han dado clase conmigo en Geología 1, ¿cuántas veces le he dicho el mundo que se abre en la oceanografía? Christoph dio una excelente charla de las posibilidades que tenemos de la minería dentro del océano. Entonces, estamos en una isla, pero no tenemos un oceanógrafo, no tenemos geólogo marino, y toda esa es una rama que está dentro del servicio geológico, pero que no tenemos representantes. Fíjense de todo lo que él habló de oceanografía, geología marina, biología marina y la minería dentro del mar. También habló como uno de las fosas más profundas, la fosa de la Mariana, que están ahí, pero nosotros tenemos la fosa de Milwaukee, que está entre Puerto Rico y República Dominicana, que es la segunda más profunda. Una isla que al norte de aquí tenemos, se juntan dos placas, la de Norteamérica y la placa del Caribe. La fosa la tenemos al este y hacia el norte tenemos el Rich del Gran Beata. Todas esas áreas pueden producir un yacimiento en el futuro. No se ha explorado, solamente se ha explorado la parte de petróleo, sobre todo en la costa de San Pedro de Macorís, pero pudiera haber un yacimiento ahí, pero no tenemos técnico. Entonces, eso le abre un mundo de posibilidades a los que están comenzando la geología, a los que algunos que están terminando ya, que están bien avanzados, pues tienen la posibilidad de continuar una maestría allá en Polonia, talleres, y yo creo que no para este trimestre, sino para el otro, iniciemos el acercamiento, precisamente con unas charlas que va a dar Miguel Peña, una materia, y que a través de esa materia comencemos como a afinar los oídos. Hasta yo estaba entendiendo al final. Entonces, es que estamos aquí y no escuchamos que nos hablen inglés. Probablemente las personas que fueron, los 3 estudiantes que fueron a Polonia, después de varios días empezaron como a entender mucho más de lo que entendían aquí. Entonces, eso le va a abrir la posibilidad de que los próximos o los que finalicen o los que comiencen de empezar a recibir algunas materias en inglés con la guía de un profesor ahí en el aula, eso le va a ir, se van a ir acostumbrando y ya no será tan difícil. Cuando dominemos el inglés, entonces vamos a aprender el polaco, que ahí sí es duro aprender polaco, pero vamos a aspirar que en 2 o 3 años la mayoría de los estudiantes, ojalá de toda la universidad, pero por lo menos del área de geología, dominen en más de un 80% el inglés, y entonces nos metemos en otra lengua. Yo quiero darle las gracias a todos los que asistieron, algunos que tuvieron que irse porque tenían clase, y le voy a pedir al vicerrector que si por favor le dé formal cierre a este magnífico evento. Démosle un gran aplauso a la delegación.
Lo que queremos dejar con este evento, sobre todo los estudiantes, que tengan claro la dimensión de esta universidad, que es un orgullo de esta provincia y de este país. Somos pública y nosotros estamos haciendo un ejercicio académico mostrando que se puede ser pública, pero de calidad. Y eso es un esfuerzo de todos, de ustedes que están estudiando, pero también de los egresados de la universidad, que tienen que ser los que proyectan día a día a esta institución. Y eso estamos llamados a seguir reforzando estas relaciones internacionales, y qué bueno que sea con la marca de la UTECO, la carrera de geología. Entonces, ojo con eso a ustedes, que tienen esa enorme responsabilidad de ser bueno y terminar siendo bueno y mejores cada día. De manera que le damos muchísimas gracias a ustedes, los técnicos de la Universidad de Cracovia, por estar aquí con nosotros y haber compartido esta inmensidad de conocimiento técnico profundo que los estudiantes han recibido. De manera que muchísimas gracias a ustedes y a los funcionarios polacos que están aquí compartiendo con nosotros. Muchísimas gracias y que Dios les bendiga.